Hi, Assalamualaikum, and very good day to the panel and audience. I'm Pbl Ismail, acting as the chairman of this project team. Our project is entitled Smart Mushroom Cultivation System and is designed in the line with Industry 4.0, focusing on the digital transformation in agriculture. In this discussion, we will explain how we successfully integrate PLC and SCADA and IoT with human-machine interface and cloud computing platform to solve common challenges in mushroom farming, such as inconsistent environment, lack of field monitoring, and manual intervention delays. Now, to begin with the technical foundation of our system, I'd like to invite Engineer 1 to explain how automation to achieve through PLC. Now, Naswa, you can start.
Okay, thank you for chairman.
Mm-hmm.
So I am Nunaswa and I serve as engineer 1 to focus about the PLC and automation system. So we use a Siemens PLC, Siemens S7 100-2000 PLC, specifically the CPU 1246 model, which is it can serve a brand to our system. It receives the input from the temperature and humidity to sensor temperature about the mushroom cultivation environment. Based on the sensor reading, the PLC can active various output because it has four, which is the first one is the lamp artificial lighting, and second water pump to regulate the humidity, and the third enhancer fan for proper ventilation, and lastly flavor valve to like control carbon oxide and nutrient mist delivery. So the entire process is fully automated using the logic block and Boolean logic, so the system can be operate continuous without the manual intervention. This logic can put optimal environmental parameter through a mushroom growth cycle to improve consistent reducing level. So I will hand on to the engineer 2 to explain how we attach and the automation to real-time monitoring through the IoT and cloud connectivity. So that's all for me. So engineer 2, can you explain?
Okay. So I am Noah Adam, and my role is as engineer 2, which is I am in charge of IoT integration and remote monitoring capabilities. Our system includes IoT sensors that get the real-time data on critical factors like temperatures, humidity, airflow, and CO2 concentration. This value are sent not only to the PLC but also to the cloud using the Node-RED, a flow-based development tool for wiring together hardware and cloud services. We also use platforms like Siemens MindSphere and Amazon Web Service, or in short form AWS, to make this data accessible remotely, which will help the company greatly. As a result, the farm operator can monitor the system in real time, receive alerts, and even make adjustments from a smartphone or PC without even being physically present on the farm. This type of smart connectivity allows for faster decision making, reduced downtime, and supports predictive actions before issue become serious. Next, we'll pass on to our technician, Mr. Rafa Izin, which will explain how operators interact with the system using a human-machine interface.
Alright, thank you, Mr. Noah, as engineer 2. So, my name is Muhammad Rafa Izin Merambi. I as a technician for this project. So, I was responsibility for the HMI system, and then the alarm system also for our mushroom cultivation automation projects. So to begin, the HMI is the main control panel for the system. It's a touchscreen interface that allow to the operator to interface with the system, and also is very user friendly to use without need to directly program to PLC. So the HMI, we can view the real-time data monitoring, which is temperature, humidity, and oxygen (CO2) level, water level (CO2), and then we can start and stop. Use the HMI system to start to stop the fans, pump, and heater, and adjust the set point to interval the temperature. Also, we can see the historical data in HMI. Okay. Next, I developed the alarm system that ensures safety and quick response during any abnormal situation. For example, if the temperature will go too high, or the humidity will drop below the ideal range, the system will immediately trigger a visual alarm on the HMI screen. Okay, so along with audio buzzer to alert the operator. This is help reduce the risk, prevent crop damage, and improve overall system reliability. One of the best feature is remote access. Okay, the HMI can be linked to cloud IoT platform like MindSphere and AWS, so user can monitor and also respond to alert even where they're offsite. This is especially useful for larger farm or multi-rooms operation. In conclusion, the HMI and alarm system make the entire mushroom farming process more efficient, safe, and easier to manage. It plays a key role in supporting smart agriculture under Industry 4.0. Thank you. And now I will pass to the data analyst. We will explain about the cloud data. Okay, thank you.
Okay, thank you, Mr. Rafa. Assalamualaikum. Hi, good evening. I'm Narasha Aziz as the data analysis for this project. One of the major advantages of our system is its ability to collect and process data using cloud platforms. We integrated MindSphere and AWS to store environmental data from our IoT sensors. With this data, we perform first joint analysis to understand the best growing conditions. Second, predictive maintenance, such as detecting early signs of fan or pump failure. And last, cycle optimization by adjusting operations to maximize mushroom yield and reduce waste. Moreover, this data-driven approach supports sustainable agriculture. By analyzing usage patterns, we can reduce water, energy, and nutrient consumption, ensuring an eco-friendly process. This makes our system not only smart, but also future ready. I think that's all from me. I will pass to Chairman. Thank you.
Thank you, team. To summarize, our project demonstration a complete smart farming solution by integrated. First is basically the real-time sensor data, Pbl Plc, and second is remote monitoring using an IoT and cloud device, and finally using by operation with a HMI, who explained by Mr. Rafa. And last is basically intelligent insight via data analysis by Rashidin. We believe this system can be expanded for wider agriculture use, not just for the mushroom, but for any crop that require controlled environment. With this project, we take a forward toward digital agriculture, contributing to sustainability, food security, and smart farming innovations. And last, thank you for your attention. We are now ready to answer any questions. Thank you, and give the report in my desk in the written letter.
Okay, I hope this project can successfully and we can work together until the project is done. Alright.
Thank you.
Thank you.
Bye bye.